Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and today we're going to talk about Unit 10, mini lesson number 4. We're going to talk about the likelihood of an event. We're going to start this conversation of a lovely thing called probability. You should be able to explain this to a friend by the end of the day. Before I begin, I want to read this lovely quote from Winston Churchill that says, "The optimist sees the opportunity in every difficulty, and the pessimist sees difficulty in every opportunity." So today, let's be an optimist and let's work through these difficult math problems, but instead of seeing them as difficult and challenging, let's see them as an opportunity to learn and grow as math students. Here we go with likelihood of an event. Okay. First thing you need to know is that probability is the ratio that describes the chance that an event will happen. A ratio that describes the chance an event will happen, okay? That word ratio we talked about way back in Unit 5. It's just a comparison of two numbers, okay? So essentially what we'll do is we'll take two numbers and compare them, and that comparison of two numbers, that ratio will tell us the likelihood or the chance that a given event will happen as a fraction, okay? Another big important word in this unit will be outcome. An outcome would be any possible result of a probability experiment. Okay. For example, the different outcomes when I roll a dice, I could get a 1, 2, 3, 4, 5, or 6. There's 6 different outcomes when I just roll one die as to what could happen. Those are different outcomes. Okay. Flip a coin, you could get heads or tails. Those are two different outcomes of two different events. Okay. Experimental probability, we'll talk about two different kinds of probability, experimental probability and theoretical probability. Experimental probability is when you determine probability through an experiment. makes sense. Okay. You find it one specific way to find the probability of an event with experimental probability. We might do this in class. You might take the number of times an event occurs over the total number of trials or attempts. Okay. Trial is just a big word for attempts. Attempts. There it is. That's a tough word to spell too. Who knew? Okay. For example, two examples. If Sam rolled a number cube 50 times, number cube is a big word for die. Okay. If Sam rolled a number cube 50 times and the number 3 appeared 10 times, we're going to find the experimental probability using what ratio? Okay. If he actually rolled his number cube 50 times, then that is our total number of trials on the bottom, and he got what he wanted, that particular event 10 times. Okay. What I would do, I would write it as a simplified fraction, like 1/5. Okay. We're always going to simplify, and we can also write it as a percentage as well. If you want to use your percent proportion from Unit 6, you find out that's the same thing as about 20%. That's experimental probability. The total number of times he rolled a 3, 10 times over the total number of times he did the experiment 50 times is about 20% or 1/5. Ed Puzzle is going to ask you what you got for number 2. If a coin is tossed 60 times and heads appears 27 times, what is the experimental probability of getting heads simplified? Please tell me what the simplified answer would be. Hopefully you chose that 27/60ths is the ratio, 27 times heads over 60 total times. Same thing as 9/20. You might have simplified that to a percentage as well, 45%. The simplified fraction answer there should be 9/20ths, this guy right here. Okay. He got heads 9 out of every 20 times in that experimental probability situation. For theoretical probability, that's the likelihood of an event happening based on all the possible outcomes. Instead of actually doing the experiment, we just sit and we make a list of the outcomes and we just think about what could happen instead. Okay? Still the same kind of situation, the number of favorable outcomes, what you want. Okay? Favorable is a big math way to say, whatever outcomes you actually want. So I'm going to write that down. For you, write down right there. Thank you very much for writing that down. Over the total number of possible outcomes. So we'll take the number of outcomes that we'd like to happen over the total number of possible outcomes. For example, if you had the vowels A, E, I, O, and U, 5 vowels, 1, 2, 3, 4, 5, in a hat, folded up in pieces of paper, what will be the theoretical probability of selecting the letter E? The truth is there's only one letter E up here out of 5 total possibilities. So the theoretical probability will be 1 out of 5. Look at that. A typo. Or do you know, Mr. R is up at midnight making this video, and he actually made a typo. Can you believe that? I can't believe that either. Okay? Let's think about that one more time. Say 5 instead of whatever I said before. That's right. The theoretical probability of selecting the letter E would be 1/5. There's only 5 vowels, not 6 of them. Okay. There's a 1 out of 5 chance I could pick the letter E. Okay. Ed Puzzle is going to ask you about this next question. If you tossed a coin onto a standard 8x8 chessboard, it has 64 squares. What would be the theoretical probability that your coin landed on a black square? Assuming that your coin landed on one square and only one square, and it landed on the chessboard itself. Out of 64 possibilities, what would be the theoretical probability that would land on a black square? That puzzle is going to ask you right now. The truth is there's about 32 black squares up there. If you count them all, you can see them all. Or you just can know about chessboards that it's half and half. Okay. There's actually a 32 out of 64 chance, a 1 out of 2, a 1/2 chance that your coin lands in a black square. Okay, so we talked about experimental probability and theoretical probability. We're going to move on to likelihood now, really quickly. It is totally possible to have a 100% probability of an event. That makes it what we call certain to happen. For example, if you say, what's the probability that if you roll a dice, you get a number 1 through 6? The truth is all the numbers on a dice are 1 through 6. So there's a 100% probability that would happen. It's also possible to have a 0% chance something would happen. That makes the event mathematically impossible. Okay? If you say, what is the chances that you roll a dice and get a 7? There's not a 7 on normal dice, so it would be impossible for you to do that. Okay? We're not going to, try to read between the lines and find loopholes. We're just thinking mathematically in terms of probability, what could happen. Okay? On this number line, fill in this blank. Each fraction is 1/4. That's 1/4 there, and then 1/2, 3/4, and 1. The percentages that correlate with those are 0, 25, 50, 75, and 100%. It would probably be nice if you knew what those fractions and percentages were to each other. That would be a nice thing to know. Okay? If we have a probability of 0, we call it impossible. If it's 100%, we call it certain. Otherwise, we have to use these different words to describe it. So if it's in between 0 and 50, we can call the event unlikely. If it's in between 50 and 100, we can call the event likely. If it's exactly 50%, we can call the event equally likely. So there are a couple different words it might ask you to use to describe it. Okay? If you think about the words for a second, they kind of make sense. If it's 0, it's impossible. 100% it's certain. It really matches up with this number line up here. If it's in between 0 and 50, it's unlikely. In between 50 and 100 is likely. Exactly 50% is equally likely. Okay? So here's a couple of you tries. I want you to write a ratio for the probability, and then I want you to call each event impossible, unlikely, equally likely, or certain. If you roll a die, you'll get a number less than 7. Think about it for a second. On a dice, there's 6 sides, and it has the numbers 1 through 6 on it. So there's 6 favorable outcomes, numbers less than 7, out of 6 possible outcomes. The probability there is 1, or 100%, and it is a mathematical certainty that would happen. It is certain that would happen. There's a 100% chance that if you roll a dice, you get a number less than 7. B says if you roll a die, you will get an odd number rather than an even number. So think about it. On a dice, there's odd numbers 1, 3, and 5. There's 3 total odd numbers out of 6 possible outcomes. okay? There's a 1 out of 2 chance if you simplify that fraction. And it's equally likely to get an odd number or an even number is what we call equally likely in the world of mathematics. So there's your answer there for you, okay? Ed Puzzle is actually going to ask you about number D, that's right. And then it's going to ask you about number E, and it's actually going to ask you about number F as well. So you got 3 different things that Ed Puzzle is going to ask you about: D, E, and F. Okay, so answer them. Very last thing, it's very important. The sum of all possible outcomes in an event always has to be 1 or 100%. We can't have the sum of all possible outcomes being less than 1 or bigger than 1, because that's all the things that could happen. Okay? Again, sum means addition. For those of you who still don't know what that means, you should. It means addition. Okay? For example, if you toss a coin, there's a 1 out of 2 chance you'll get heads, a 1 out of 2 chance you get tails. There's nothing else that could happen, and 1/2 plus 1/2 is 1 whole. The total sum of all possible outcomes always has to be 1. Okay? Thank you for paying attention to this video. Really appreciate it. Have a great day. Make it a great day or not. The choice is yours. My answer key is on the counter for any questions you might have. Thank you very much. Have a great day.